Hi, welcome to the screencast, and we're going to look at how we can solve area problems that are polynomial problems, and I'm going to show you how you set them up and then how you solve them. So let's look at this problem about a triangle. The question actually asks what are the dimensions of this triangle that work for the given area. So they are giving us polynomial expressions to represent the base and the height, and then they tell us the area, and then we are going to have to write a polynomial equation and then solve that. So let me copy that down, and then you can also copy it down. So here's my triangle, and the height of the triangle is represented with 2x minus 3, and that would be centimeters. And the base is 2x plus 1, and that's also centimeters. And then the area is this. So I need to first remember the formula to find the area of a triangle. So area equals 1/2 times the base times the height. So now I'm going to use the polynomials I have, and I'm going to put them into the formula. So now that I filled in all the parts, I have the area over here, which is 2.5 centimeters squared, and I'm 1/2 times the height times the base. So to solve this polynomial, I have to first I'm going to have to expand it. Then after I expand it, I'll set it equal to 0, and then I have to refactor it. So let's first expand this polynomial. So I'm going to use FOIL to multiply these two binomials by each other, and then I have to also multiply by 1/2. So pause the video now and multiply that out on another piece of paper, and then you can check your answer. So I expanded, and then I multiplied everything by 1/2, and here's where I am. So at this point, in order for me to solve this polynomial, I have to now subtract the 2.5 from each side so that one side of this equal sign equals 0, because I need it to equal 0. So when I subtract here, I get -4. So I'm going to rewrite the other direction. So I'd have 2x squared minus 2x minus 4, because -1.5 and -2.5 equals 4, and that equals 0. So then I'm going to, to solve this polynomial, I need to factor it. So before it was factored, but I had a number over here. So in order for me to combine that with what I had, I need to first expand it, simplify it, then I could subtract the 2.5 from both sides. And now in order to solve a polynomial set equal to 0, you have to factor it. So I'm going to look for the common factor. I notice right here I have the greatest common factor for these terms is 2. So I can factor out a 2. And then I can factor this polynomial. So that would be -2 and +1, because my outer will be +1 and the inner will be -2. And -2 plus 1 is -1. So now from here, now I have it factored. In order for me to continue solving it, since it equals 0, I set each binomial, I write an equation where x minus 2 equals 0 and x plus 1 equals 0. So I'm going to do that up here. X minus 2 equals 0. If I solve that equation, I add 2 to both sides, I get x equals 2. Or x plus 1 equals 0. Well, that would be x equals -1. And since we're talking about centimeters, the -1 answer doesn't make any sense. So the 2, that doesn't have an x with it, so you don't need that. I set that equal to 0. 2 doesn't equal 0, so that's done. So it looks like my solution is x equals 2. But that wasn't the question. The question was, what are the dimensions of the triangle? So now I know x equals 2, so I go back up here. And so I would do 2 times 2. I substitute in the 2, minus 3. So that's the height equals 1 centimeter. And then over here I go 2 times 2 plus 1, and the base equals 5 centimeters. And so now I can check. If my base was 5 and the height was 1, and I did 1/2 times the base times the height, I would get 2.5. So yay, I have the right answer. So that is how you set up and solve a polynomial equation. I'm almost done, but just not yet. So let's just look at this last example, and I'll take you through the different steps as we go through this. So this is something that you want to write down. So when you're given you're giving two parts, either whether it's because you've written a word problem yourself or you have been given this out on paper, and I have these two binomials being multiplied by each other and they equal a number over here. The first thing I need to do is expand this and write it as a trinomial. So here I've done that, and I expanded it, and I have 4x squared plus 2x minus 30. That equals negative 28. So from now to solve it, I need to set it equal to 0, and I'm going to do that by adding this negative 28, give a positive 28 to both sides. So give a positive 28 to both sides to solve it and make it equal to 0. So I'll have 4x squared plus 2x minus 2 now equals 0. So once I have my whole equation equal to 0, now I'm going to factor it. So I'm going to factor out the GCF first. So the greatest common factor here is 2. I'll have 2x squared plus x minus 1 equals 0. And from there, I'm going to factor it into two binomials. So pause again and try that. So here's what I have, and now I'm going to check it. So that would be 2x squared, outer would be plus 2x, inner would be minus x, last would be negative 1. So I would have 2x squared, these two terms become 1x, and I have minus 1. So there, I found the correct factor. That's how I check my answer. So it means 2x minus 1 and x plus 1 are the two binomials I'm going to set equal to 0. So I'm going to write two equations. 2x minus 1, that's the first one here, equals 0. And I'm going to write x plus 1 equals 0. Because if I made this graph, it would actually hit the x-axis in two places. So that's our two solutions. So I'm going to add 1 to both sides. 2x equals 1, x equals 1/2, or minus 1, x equals negative 1. So our two solutions are x equals 1/2 and x equals negative 1. Now, if this was a word problem and it would only make sense for the answer to be positive or negative, then we would only use one of the two solutions. But in this case, it doesn't really matter. Now, I should be able to put these values in for x at the very beginning, and I should be able to get negative 28 when I multiply. So why don't you try that with 1/2 and see if it works. So when I substitute, my first solution I had was x is 1/2. So when I substitute that in here, and I put a half in wherever I saw x, then for the first, I had 1 minus 5, which is negative 4, and 1 plus 6, which is 7. So negative 4 times 7 is negative 28. I'm going to do the same thing with negative 1. So I'm going to put negative 1 in for x. So I'd have 2 times negative 1 minus 5 for my first binomial, and 2 times negative 1 plus 6 for the second one. And when I multiply those results, I should get negative 28. So here, I would have negative 2 minus 5 is negative 7. And I would have negative 2 plus 6 is 4. And when I multiply them, I get negative 28. So both of those solutions work in the original equation, so I can be confident about my answer. So here are your two solutions. So then those are the steps. So first, when you're given these two binomials being multiplied and they equal something, the first thing you have to do is expand it, and then you would set it equal to 0. And then after you set by subtracting the other constant from both sides, or adding, depending on whether it's positive or negative, then you would after you set it equal to 0, you would factor the trinomial you were given into two binomials. Then each binomial equals 0, and you solve that equation for your solution. So hopefully that helps you in solving polynomial equations. Thanks for watching.